This video is for Lesson 4-7, Chapter 4, Lesson 7. Your learning target today is to be able to divide fractions. Please open your textbook to page 318 and get your materials ready. For us to divide by a fraction, we simply are going to multiply by its reciprocal. We talked about this in the previous video, that we can follow the rule of keep, change, flip, or I like to call KCF, or Kentucky Chicken Fried. Okay, so what we end up doing is keeping the first fraction the same. We change the division to multiplication, and we flip or use the reciprocal so that we can avoid using division. So let's look at the examples up here. We have 5/6 divided by 2/3. Well, following our rule of keeping it, we bring the 5/6 over, we keep it the same. We change the division to multiplication for step 2, change. And then instead of using 2/3, we use its reciprocal of 3/2, meaning we just let it switch places. The numerator and denominator change places. Okay? We could also express this without numbers and just using algebra, which simply means that we're using letters or variables to represent mystery numbers. If we had a over b divided by c over d, that's the same thing as saying let's go ahead and keep the first fraction. A, b is the same. We change the division to multiplication, and we flip or use the reciprocal of CD, which then turns into D over C. So remember, today it's going to be pretty simple. Same things. We're going to keep the first fraction, change to multiplication, and then we use the reciprocal or flip the second fraction. Before we move on, though, I do want to point out that we need to remember our parts of a division problem, that inside the box is the dividend, and this represents the whole or the total amount that you have. And please add this into your notes. We also need to remember that the divisor is the number of parts that we want to divide it into. This will help us later when we get into our division problems. And then our quotient is the answer. So please take time to add these notes into your book. It'll help us when we get to our story problems here at the end of this lesson. So starting off here with example 1, they're using two methods. They are going to use a model. And to be quite honest, I think the model is confusing. I'll label it out for you. They say first, let's go ahead and use this problem of 1/2 divided by 1/3. And so for step 1, they said go ahead and use the model to model the dividend, which is 1/2. So that's up here, step 1. They take the long rectangle and cut it in half. And then step 2, they divide the whole box into thirds, because of the second fraction says divide into thirds. So this is step 2. They made a second drawing, and at this point then they cut it into these thirds. And then step 3, they said count the number of 1/3 sections in a half, and so that's represented here in this last picture, that there's 1 and a half of another section of a third. So to me, it doesn't really lay it out all that nice for me. It's a little hard for me to understand a little bit. So I would prefer that we kind of ignore this one and go ahead and go to method number 2. So using method 2, I'm going to go ahead and write my little reminder up here. We're going to keep, change, and flip. Remember, flip means use the reciprocal. So when they start up here, they go ahead and talk about 1/2 divided by 1/3. So they take 1/2 and they rewrite it. They keep it the same, because that's step 1, keep. We change the division sign to multiplication. they take 1/3 and they flip it. They use the reciprocal of it. So you can draw your arrow on here. And so the 3 now moves to the top, or is the numerator of the fraction, and 1 becomes the denominator. Then we can simply go ahead and multiply. 1 times 3 is 3, and 1 times 2 is 2. And we know that 3/2 is improper, so we have to fix that. So if we take our 3/2, what we're really doing is thinking in our head 3 divided by 2, and we can take out one whole group, and then we'll subtract 2 off of our numerator, leaves us with the remainder of 1 over 2. So our final answer then is 1/2. 1 and 1/2. So if we go back to that previous slide on the model, then in that last picture, we had the half cut, and then they cut the box into thirds again. And if we look at this final answer, we said that, this was worth 1/2 of the total rectangle, and this was worth 1/3, and then we had this was worth another 1/3, and so we were talking about, we got one whole section of 1/3 plus we got half of the next section. So that's how the model kind of lays out for us. So let's try a couple here, and remember, let's put our reminder up here. We're going to keep, change, flip. Yeah, that's the action, remember from the video? So I'm going to keep my 1 1/4. I'm going to change my division to multiplication, and then I'm going to use my reciprocal of 3/8, which becomes 8 over 3. Now I can go ahead and multiply. 1 times 8 is 8, and 4 times 3 is 12. So that looks like a really nice answer. It's proper. The numerator is smaller than the denominator. However, anytime we work with fractions, we have to simplify. So I know that 8 and 12 have a factor of 4. So I'm going to divide them both by 4, and I'm going to get simplified down to 2 over 3. So my final answer is actually 2/3. Let's try the next one. We're going to keep the first fraction. We're going to change the division to multiplication, and we're going to use the reciprocal, or flip, the second fraction, so it becomes 8 over 3. So now we can multiply. 8 times 2 is 16, and 3 times 3 is 9, and we have an improper fraction. So we need to resolve that. We can't leave it like this. So I'm thinking in my head, 16 divided by 9. How many groups of 9 can I take out of 16? I can take out one group. So one group of 9 is 9. So subtract that away from the 16. And my remainder then will be 7. So our final answer is 1 7/9. Why don't you go ahead and try C on your own. Pause the recording while you do the work, then turn the recording back on to see how I solve the problem. Okay, so hopefully you got the final answer of 2 1/2. This one was difficult. There's a lot of steps at the end. It's not like they're hard numbers, but there's just multiple steps. You need to bring down the 5/6, change division to multiplication, use the reciprocal of 1/3, which is 3 over 1, and you get 15/6, which is improper. So we're thinking in our head 15 divided by 6. I took out 2 whole groups, which means I've used up 12, so I subtract, and my remainder was 3. 2 and 3/6. Well, 3/6 then is half of a pizza, 3 out of 6 slices. So we can divide 3 and 6 by the factor 3, so that gets us down to 2 1/2. So here on example number 2, what they'd like us to do is to write a story problem. So context means write a story problem. for a division problem with fractions, 2/3 divided by 1/6. So what they used was, they said this girl, Mariska, has 2/3 pounds of sunflower seeds, and each day she feeds the cardinals in her yards 1/6 pounds of seeds. Okay? And then they want to know for how many days will she be able to feed the cardinals. So they used a model to show it. Otherwise, we would actually go ahead and do division. And if you don't, I'm not big on using the model to solve things, so you can go ahead and just use your numbers. I'll just say solve on here. I'm going to say go ahead. You do not have to use the model. So up here, let's go ahead and label this. That 2/3 then, is the total, which means that we're going to use it as the dividend, and 1/6 then is the divisor, or because it's the parts, how many parts that we want to cut it into. Okay, so when we're down here for the total, to write a story problem for the God at D, 3/4 divided by 1/8, remember that the 3/4 is your total, or the dividend, and 1/8 is your parts, the number of parts that you want to cut it into. So that means it's kind of like if we had a division problem, we'd be saying 3/4 divided by the 1/8. Those are the positions they're sitting in. On this one up here, it would have been 2/3 inside the fraction, or inside the division house, divided by 1/6. So I'm going to say that I have 3/4 pound of fudge. I like to eat chocolate fudge, like the candy. And I want to cut it into 1/8 pound chunks. So my question then is, how many chunks can I cut? Okay, so then I'm going to go ahead and solve it. So I'm going to write it up over here. 3/4 divided by 1/8. So I'm going to use my keep change flip. So it's going to be 3/4 times 8/1. So I get 8 times 3 is 24, and 4 times 1 is 4. And so 24 divided by 4, that's in an improper fraction, or 24/4 is improper. And when I do the division, then I get 6. So I could get 6 chunks. And each of those chunks then weighs 1/8 of a pound. So tonight on your homework, I don't expect you to use this model here at all. I would just say solve it using your fractions, your keep change flip. But I don't want you to wimp out and not write a story problem. Use these two problems to help you write one. All right, well, we aren't always going to divide fractions by fractions. Sometimes we'll divide them by a whole number. And so we're going to follow the same principle that we use back in lesson 3.6. In lesson 4.6, we took like 12 divided by 1/3. So we simply changed the 12. We can't use it as a whole number. We have to change it to a fraction. So we put it over 1, and then we got to multiply by the reciprocal, and we could solve. Well, tonight we are actually going to do the same process, except for the whole number is going to be in the second position. So we're actually going to have to flip it. Here in lesson 4.7, we're going to say 1/3 divided by 12. We'll follow the same procedure. We're going to keep the first fraction, change division to multiplication, and then before we can do any changes, we have to make that a fraction. So now I use my reciprocal of it, so I'm going to multiply by 1/12. So 1 times 1 is 1, and 3 times 12 is 36. So your answers are different when you have the whole number in front versus in the second position. So let's take a look at this one. They took 5/7 divided by 10. The first thing you have to do is change this 10, the whole number, into a fraction. So it would be 5/7 divided by 10 over 1. Now we can go ahead and use our keep, change, flip. We're going to keep the first fraction, change division to multiplication, and use the reciprocal of 10 over 1. So it becomes 1/10. Then we can multiply. And actually, what they did is they simplified ahead of time. They saw that here, the 5 and the 10, we did this back in the multiplication lessons, like in 4:4 and 4:3, that we could divide the cross products here by 5 ahead of time and simplify to 1, and 10 divided by 5 is 2. The 7 and the 1, the only factor they have in common is a 1, so we just leave it as is. This helps us because then we don't have to simplify our final fraction. So 1 times 1 is 1, and 7 times 2 is 14. So that's our final answer, 1/14. Now if I didn't do this simplification process right here, what it would have looked like was 5 times 1 over 7 times 10, which gives us 5/70. And hopefully if you remember your divisibility rules, you should recognize that 5 and numbers that are like 5 or end in 0 or 5 are compatible. So we would have taken that 5/70 and we would have had to divide by 5 to simplify. And 5 divided by 5 is 1. Now the 70 divided by 5, I probably would have had to do a little chicken scratch here on the side. 5 goes into 7 once. Multiply, subtract, bring down the 0, and 5 goes in there 4 times, 20, we have a remainder of 0, so it would be 1/14. We ultimately get to the same answer from here to here. They're the same. However, by doing this step right here, this simplifying ahead of time, helps us get straight to that final answer, and we have less, we might not have to do this kind of chicken scratch over here. So let's try a couple. We're going to first start by rewriting our fraction, and we're going to keep it as a division problem for right now. We're not going to do our keep, change, flip yet because we have to change the 4 into a fraction. And now I can do my keep, change, flip. So we have 8/9 times 1 over 4, because we reverse or use the reciprocal of 4 over 1, which is 1/4. So we multiply, and before I multiply, I'm actually going to simplify. The 9 and the 1 can't be simplified, but that 8 and the 4, I can divide them both by 4. So 8 divided by 4 is 2, and 4 divided by 4 is 1. So 2 times 1 is 2, and 1 times 9 is 9, and that's simplified and in good shape. Now if I didn't simplify ahead of time, I would have been doing 8 times 1 over 9 times 4, and I get 8 over 36. And then I'd have to recognize that I could divide them both by 4, and I get 2/9. So the same answer, but this simplification step right here really helps me just get down to that simplified answer right away. Let's try the next one. We're going to rewrite the whole problem, keeping the division and writing 8 as a fraction, which means put it over 1. Now I'm going to do my keep, change, flip. 4/5 stays the same. Change to multiplication, and now I'm going to use the reciprocal, which would be 8 over 1. So I can go ahead and I see I can simplify ahead of time. The 5 and the 1 can't, but the 4 and the 8, I can divide them both by 4. So 4 divided by 4 divided by 4 is 1. 8 divided by 4 is 2. So we get 1 times 1 is 1, and 5 times 2 is 10. So if I hadn't done that, I would have had to do 4 times 1 over 5 times 8, which is 4/40. And hopefully you would recognize right away that you could divide them both by 4, and you get 1/10. So you get to the same spot. This is sure handy, but if it gets you confused, go ahead and just do the regular division. So why don't you go ahead and try G over here on your own, pause the recording, and then turn it on to see if your work matches mine. All right, so hopefully you got 3/13, and on this problem, the simplifying ahead of time really helped, because I could divide the 12 and the 4 and get 3 and 1. So 1 times 3 is 3, and 13 times 1 is 13. But if I hadn't, I would have done 12 times 1 and gotten 12. 13 times 4 is 52. 12 50-seconds, I mean, I could have divided by 2, and then I would have had to divide by another 2, or hopefully you'd recognize I can divide them both by 4. It's just a lot messier. So hopefully you were able to simplify ahead of time and get to 3/13 on your own. All right, one last problem before you get to work on your own. Let's take a look at this story problem. Ramon is making party favors. He's dividing 3/4 pounds of almonds into 12 packages. So right away you need to stop. Which one of these is your total and which one is the parts? Well, I have a total of the 3/4. That means this is your dividend. Remember, it's total divided by the parts. Go back to your notes way back on the other page. So the 12 packages is our parts. So it's going to be 3/4 divided by the 12, not 12 divided by 3/4. He said he is dividing this 3/4 into the 12 packages. So that means the 12 is our divisor out in front. So we walk through it following our procedures. We change the 12 to a fraction over 1. I don't like that they didn't write that on here. It should be over 1 like this. Then they used the keep change flip, and they took 3/4 and kept it the same, changed division to multiplication, and used the reciprocal of 12 over 1, which is 1 over 12. So they used some cross products here. They simplified by 3. They divided 3 by 3 and got 1. 12 divided by 3 is 4. So 1 times 1 is 1, and 4 times 4 is 16. So there will be 1/16 of a pound of almonds in each of the 12 packages. All right, it's time for you to work on the practice assignment. Come get the assignment from your teacher or from the board and give it a try. If you have questions, make sure you're coming and asking for help.